Hi, my name is Bruce Lipton. I'm a former research scientist and medical school professor. I earned my PhD at the University of Virginia on studies of cell biology. I later ended up at the University of Wisconsin School of Medicine, where I was a professor in the Department of Anatomy. While there, I was teaching medical students and also carrying out my own research. While I was teaching in the medical school, I was teaching a concept called genetic determinism, the belief that genes control the character of our lives. The significance of this idea is that at the moment of conception, we received a set of genes from our mother and our father, and that collectively these genes come together in what is called the zygote, the developing embryo, and that through the rest of our lives, that these genes determine the character not just of our physical existence, but genes were also thought to determine our emotional and behavioral characteristics as well. Well, there's a problem with this kind of thinking, and that is this. When we believe that genes turn on and off by themselves, a process called self-actualization, it means that genes were operating without our involvement. And why is this so important? Well, as far as we know, we didn't pick the genes we came with. And if we didn't like the characteristics of the genes we have, we couldn't change the genes. And since the genes were acting on their own and we didn't control them, it really came down to the concept that we are victims of our heredity. The idea that if in our family there's cancer, diabetes, Alzheimer's running through our family, we get to believe that these are the results of genes that we inherited. And as a result, we also then believe that we are victims because since we can't control these genes, we just wait until sometime during our life that these genes turn on and off and in the process control who we are. Well, the relevance about all this is being victims, we have no control over our lives, and therefore we feel powerless. And when we feel powerless, of course, we look for others to help us, such as the pharmaceutical industry. Well, I was teaching the concept of victimization called genetic determinism. That's the term that means genes determine the character of our lives. It really led to the belief that when we were born, our future was already predetermined by the genes we received from our parents. Well, the relevance about all this is very important because what it really says is this. We have no control over our lives, and that issues that run in our family are going to affect us as well. And therefore, some of us have very negative opinions about our future for a very simple reason. It says, well, if there's cancer running in this family or cardiovascular disease, I can expect to get those as well. Well, I was teaching the concept of victimization, but at the same time, I was carrying out my own research on stem cells. Now, what are stem cells? Stem cells are the equivalent of embryonic cells. Let's start off with a very big picture. While you see me as a single living organism, you have to understand a very important fact, and that is this. I'm not a single organism. I'm made out of 50 trillion cells. The cells are the living organism. So by definition, when I say Bruce, which is my name, I'm also using that name to represent a community. Bruce is not a single entity. Bruce is a community of 50 trillion cells. The relevance about this is that as we are living, our cells have a lifespan and they die off, normal attrition. Sometimes we damage ourselves in accidents and we can replace ourselves as well. So the very important understanding is this. If we are losing our cells, and apparently we may lose hundreds of billions of cells every day, the question is, how many days can we go without replacing the cells? And the answer is, you can't live if you don't replace the cells. Well, then the next question is then, where do the replacement cells come from? And then we return to the story of stem cells. Stem cells are in your body right now. They're the equivalent of embryonic cells. A stem cell can become anything, muscle, bone, skin, brain, any of these things. It's an embryonic cell that's still in your body. And we call it a stem cell because since you're born, we still can't call them an embryonic cell anymore. So stem cells are multipotential cells in your body that are used to replace damaged and lost cells that we experience every day. And what was my research based on? It was based on cloning stem cells. Now, the research I'm talking about is over 50 years ago. In 1967, at the University of Virginia, I was cloning stem cells. At that time in our world, there were only a handful of people that even knew what a stem cell was. So I was in a very unique situation, in a very unique environment to carry out research long before most people even knew what a stem cell was. What was my research? I would take one stem cell and put it in a dish all by itself. And then what would happen is the cell would divide every 10 or 12 hours. So first there's one cell in a dish, then there's 2 cells in a dish, then there are 4 cells in a dish, and then 8. Every time the cells double the population every 10 or 12 hours. So the result is, after a week, how many cells do I have in the Petri dish? Well, I have about 30,000 cells in the Petri dish. And I say, well, what's important about these cells? And here's what it is. They all came from one parent cell. The point is, then I have 30,000 genetically identical cells in the Petri dish. They all have the same genes. Now, the experiment I did was simply do this. Take those 30,000 cells and split them up into 3 different Petri dishes. So each dish had genetically identical cells in it. But what was different was I used different versions of culture medium. Well, culture medium, that's the solution I grow the cells in. I say, what does culture medium represent? And the answer is very simple. Culture medium is the equivalent of blood. So if I'm going to grow human cells in a Petri dish, then I'm going to find out what components are in human blood and then make a synthetic version that we call culture medium. If I grow mouse cells, well, I look at mouse blood and see what's in that blood and create a synthetic version of that and call it mouse culture medium. Okay, here's the story. I have 3 dishes, genetically identical cells in all 3 dishes. But when I synthesize or make my culture medium, I have an opportunity to change the composition a little bit. So I make 3 slightly different versions of culture medium. The culture medium is the environment in which the cells live. So the point is very simple. I have 3 dishes, genetically identical cells in each dish, but each dish is fed a slightly different form of culture medium, a slightly different chemistry. And I say, well, what was the result? And the result is simply this. In environment A, with culture medium A, the cells form muscle. But in environment B, with a different culture medium, environment B's culture medium, the cells form bone. And in the third Petri dish, with a different culture medium, the cells form fat cells. So what was the important point here is, the question is, what controls the fate of the cells? Number one, they all had the same genetics. So we can't say there were different genes that caused whether it was going to be muscle, bone, or fat. I say, then what causes the development of the cells into those different cell types? And the answer is this. It was the chemistry of the culture medium. And when I changed the culture medium chemistry, I changed the fate of the cells. And why is this important? Because all of a sudden it says the genes did not control the fate of the cell. The culture medium environment controlled the fate of the cells. And in different culture medium, different fates. And this becomes very important because it says that genes are not controlling themselves. That's the old belief, genetic determinism. Genes turn on and off and control themselves. I go, no, this is not true. In the experiments, it showed that the environment, the culture medium in which the cells live, is the factor that controls the fate of the cells. Well, this becomes a very important story because it says what? It says, I can change the environment of my cells. And if I change the environment, then I change the fate of the cells. Well, genetic determinism says I'm a victim. The cells are running on their own and I have nothing to do with it. The new science that I was showing about how environment controlled the cells offered a chance for personal empowerment. I mean this for this reason. If the fate of the cells is controlled by the environment, I'm the one that can control the environment. And if I change the environment, then I change the fate of my cells. So I'm not a victim of my cells. I am a master of my cells because I'm the one that determines the environment, which in turn controls the genetics of the cell. And as a result, the cloning experiments I did back in 1967 provided a new insight to science. It wasn't genetic determinism anymore. It was environment controlling genes. And I go, oh, Well, back when I first did the experiments, my colleagues in the medical school looked at it and said, well, that's crazy experiments because we all know that genes control life. I said, wait a minute. My experiments are reproducible. I can predict what the outcome is going to be before I even do the experiment. Prediction is the hallmark of science. If you can predict something, that means you understand how it's working. And what I was showing my colleagues was that I can predict the fate of the cells, not by changing the genetics, but by changing the environment. And this is completely different than the education we were giving to medical students, that genes were controlling their own expression. So what I saw was something brand new. While my colleagues didn't understand it and they didn't support me, it took 23 years later, in 1990, science recognized what I saw back in 1967. And that is the important point, that is this. The environment is controlling the cells. The new science is called epigenetics. What's the difference? They almost sound the same. Genetics, epigenetics. Well, here's what the difference is. When I say genetic control, which is the old belief, that means control by genes. That's what we thought. Genes controlled our lives. But the new science, the one that I saw 50 years ago, is called epigenetic control. What's the difference? Well, epi means above. That's why we call skin epidermis, because the skin is above the dermis. So when I say epidermis, that means above the dermis, the skin. When I say epigenetic control, what I'm saying is simply this: control above the genes. Well, what control is above the genes? Well, right now, the very simple insight from my experiments back in 1967 is that the environment is above the genes. It's the environment that controls genetic activity. And because of this, there's a new insight to the world. We don't have to think we are victims anymore of our genes, because we can adjust our environment. And if we adjust our environment, we adjust our genetics. And if we can do that, then we are not victims of the genes, we are masters of the genes. And this is what the cloning experiments I showed in 1967 revealed, that we control our genetics. And the new science, epigenetics, is the science of how environment, and more importantly, our perception of the environment, is what controls our genes. Point is very simple. If I change my environment, or more specifically, I change my perception of the environment, I am then changing my genes, and I am controlling my gene activity with my mind. And this becomes so important because it says, no, we are not victims of our genes. We are masters of our genes. We control our own genetic activity. In this section, I would like to talk about how life works. And to understand that, what we have to recognize is this. Before you study biology, you have to study a more fundamental science called physics. Physics is the science of the mechanisms of the universe, how the universe works. It's mechanics. That's exactly why we can say Newtonian physics or Newtonian mechanics, quantum physics or quantum mechanics. Mechanics means mechanisms, how the universe works. Before there was Newtonian physics, the church was running a world that said that things work because God and Spirit are controlling us. So there were invisible forces that were shaping the existence of our lives on this planet. But around 1600s, a new development called the mechanical clock was created. And it was at the same time that Rene Descartes was doing his research. Now, most people think of Descartes in regard to separating the mind from the body. But Descartes also, as a philosopher, came into a new idea, because when he observed the mechanism of the clock, that you could tell time with the clock, he also noted you could tell time by watching the planets and the stars moving. And all of a sudden he got an idea, and he says, what if the universe is like a giant clock, a giant mechanism? Well, he came up with the idea that was a mechanism, but there was no way to study that. It was only around 1700 when Isaac Newton started to look at the universe like Descartes and said, maybe it is a mechanism, maybe it is like a giant clock. And to understand how it would work, he would have to understand how the planets and how the stars were moving. Well, to do that kind of research, actually, he had to create a whole new mathematics. In other words, before Isaac Newton could create physics, he created a new science called calculus. Calculus is a way of measuring the physical universe and seeing what happens over time as time changes. So Isaac Newton creates calculus. And then to study the universe, he studied the movement of the planets around the sun. So he used his calculus equations to study this movement over time. And what kind of information did Isaac Newton put into his calculus equation? Physical information. The size of a planet, the mass of a planet, how fast the planet was moving in its orbit around the sun, physical data like that. And when he put this data into his calculus equation and solved the equation, Newton was able to predict the movements of the universe. Now remember, prediction is the hallmark of science. So because he was able to predict the movement, it was understood that he understood the mechanism of how the universe worked. And that's what he solved in his calculus equation. But in the process, what he had to do is recognize this. The universe is made out of two elements, an invisible energy, spirit, whatever that is, and a physical reality, the reality of the mechanics of things like people, trees, animals, plants. These are physical actions. And so therefore, he said that there's a physical universe and an energetic universe, but guess what? They don't interact together. He said if you want to understand how the physical universe works, which includes the human body, you don't have to bring in energy, because in his equation, he didn't put God or spirit into it, and yet he was able to predict the mechanics of the universe. So in Newtonian physics, the emphasis is on matter, materialism. That in Newtonian physics, we don't give much support for the energy in the universe. We say that's separate from the physical realm. So once mechanical physics were introduced, the idea of a material universe, then science began to look at how the physical universe works. Well, here comes an issue. Sometimes things in the physical universe are way too complicated. Well, yes, I'm going to study the physical universe matter. Some matter is way complicated, like a human body. How can you study something complicated? And the answer is take it apart and study the pieces. In science, this is called reductionism. So guess what? In the earliest science on human life, the first science was gross anatomy, what you could see with your eyes. In fact, the very first science was just labeling the parts of the body, arms, wrists, elbows, knees, just naming what you could see. But then they started to cut open the human body and look at the physical pieces on the inside. And that's when we found the organ systems, the digestive system, the respiratory system, the nervous system, etc. And they started to look at those and they said, well, how do they work? But they were still too complicated. So they started to take apart the organs. And what did they find? They were made out of cells. And they said, the cells are the building blocks of the human body. But then how does a cell work? So biochemistry was a new science. It started to take apart the cell and see what kind of chemicals a cell is made out of. And guess what they found? There are three major chemicals that make a human body. Proteins are the largest amount of chemical. Then there are fats and sugars. And then there are nucleic acids. So there were three major molecules that make up the human body. Since proteins were the largest component, they were looked at first. And in fact, the name protein in Latin means pro, primary, teen, part. Protein means the primary parts of the cell. And guess what? As they started to look at how many proteins in the body, they were found thousands of different proteins, all kinds of proteins. And they said, well, yeah, but since proteins are the major part, they provide for the structure, they also provided for the behavior. How can a protein provide for structure and behavior? Well, the first thing is this. What is a protein made out of? Biochemistry takes that apart, reductionism, and finds that there are chemical groups called amino acids. there are 20 different kinds of amino acids. And in fact, if you go to the health food store, you can find that there are different amino acids on the shelf, and that these amino acids are actually the building blocks that create the proteins that make up our body. And I say, well, what makes a protein? And the answer is simply this. A protein is like a poppet bead chain, where each of the beads in this chain represents one of the 20 different proteins. And I say, well, how long is the chain? Well, I say small proteins may only have 20 small amino acids in the chain, but large proteins could have thousands of amino acids strung together. But when you look at my model of the chain, it says it's all strings. It looks like spaghetti. I say, well, if all proteins look like spaghetti, then why doesn't a human look like a bowl of spaghetti? And the answer is this. This model is not accurate. Why? Because it looks like all the amino acids are the same shape and the same size. Well, that's because I just wanted to show you that all amino acids are strung together in a chain of beads. But the fact is this. Each amino acid has its own shape and its own electrical charge. So there are 20 different shapes, and each of them can be positive or negative or neutral. So what I would like to introduce to you is not poppet beads. Let me just show you 3 models of 3 different amino acids. And remember, these are 3 amino acids out of a possible 20 different ones. Okay? So let's say I have this yellow amino acid with this shape. I have this blue amino acid with this shape, and a red amino acid with this shape. I say, yeah, but as I showed you in the poppet beads, the amino acids plug together like chain of beads. So I can now plug my amino acids together and create a chain. But as you can see, as I'm creating this chain, it doesn't look like poppet beads anymore. It has a 3-dimensional structure. So as I add more amino acids, my structure becomes more and more complicated, and each complication is due to adding a different shape amino acid. But in our study, we're only using 3 amino acids, red, blue, and yellow. So let me put this chain together, and I go, here, this is like a poppet bead chain. This is a sequence of amino acid, but guess what? Now it has a 3-dimensional structure. I say, yeah, so what is the shape of a protein? I say, it's due to the sequence of the different amino acids. And remember, there are 20 different ones. I'm only showing you 3. And if I say 20 different shapes, I can get a very complicated structure. I go, yes, but guess what? It's all a single string. There is no branches to it. It's one string, but because each of the equivalent of the beads has a different shape, the string is not just a plain flat string, it has a 3-dimensional structure. Well, that's part 1. Now that we've understood that the sequence of amino acids determine the linear structure, there's a part 2. And that part 2 is this. Remember, amino acids not only have a unique structure, they also have a unique charge. And why the charge is important is, look at this model. What model should I show you? This one, or can I twist it and show you this one? I say it's the same thing, but look at the shape. It's very different. So I say, well, what shape should it have? This is where the charges come in. And here's the point. Imagine these 2 yellow amino acids at the end are negatively charged. And I ask you, which is the better shape? This one or this one? And the point is, well, which one is better? And the answer is this. Since the yellow amino acids are negatively charged, they have the same charge, like charges repel each other. So the farther away the 2 negative charges are, the more stable is this molecule. So I say, yes, instead of this, the protein would like to have this particular shape right here. But then I say, well, wait a minute. If I have all these positive negative charges, then the final shape of the protein will twist and turn and adjust itself to create the best and final shape. Well, to illustrate that, let's look at this video. In this video, you can see that a protein starts out as a string. But along the protein, the amino acids have negative and positive charges, so we illustrate that as the sequences like this. But then I say what? Well, if you let go of the string, what's going to happen? And the answer is this. Like charges, 2 positives will repel each other. 2 negatives, they'll repel each other. But a positive and negative attract each other. So based on the charges, the shape of the protein will adjust itself to balance all the charges. So when you see the following, which occurs in less than a tenth of a second, what will happen is the protein will fold itself up to balance the charges and create a final three-dimensional shape. And as you can see in this picture, the molecule automatically knits together and comes to a final shape as a result of balancing the charges. So that's the shape of a protein. That's the shape that gives us the shape of our body. But guess what? Our bodies move. I said, well, how does the body move? And I said, well, the proteins not only provide for the structure, but the proteins provide for the movement. I said, well, how does that work? So let's go back to our model of a protein. And I say, our best model that we saw is when the two yellow amino acids are far apart from each other, that is more stable than if they're close to each other. So I say, let's say in our model right here, this is the more stable configuration. The two negative charges are far apart from each other. But then I say, guess what? And this is the secret of life. Life is based on movement. But these proteins are now very stable. They have a final structure. And guess what? Proteins give us a stable structure. In fact, when a person is dead, the shape of the body, the cadaver, is due to the proteins. But there's no movement in a body. So proteins can provide for the physical structure, but they also provide for the movement. I say, well, what causes the movement? Now watch this. Here is our model right now, okay? And I say that the yellow is negative on each side, and as a result, the negatives are far apart from each other. But here comes the secret of life, and it's based on environmental signals. So let's say this is a chemical, and it has a very positive charge. And I said, but what's the charge at the end? I say the charge at the end is negative. And I said, well, what happens if I have a positive and a negative? And the answer is simply this. When I have a positive and a negative, the positive will bind to the negative. So the molecule of the chemical that is very positive will bind to the negative amino acid. But guess what? Now, at the end of the protein is negative on this side, but it is now positive on this side. So I say, well, what will the protein do? And I say, the protein will move, and it will bring the positive and negative together. And so I say, yeah, the protein started out in this structure, but when the signal bound to the protein changed the charge, the protein changed its shape. Well, wait, changing shape, you just saw it. What does it represent? Changing shape causes movement. It is that movement that creates life. And guess what? If this signal pops off, when the signal pops off, now there's two negatives, and guess what? They'll start to repel each other, and then the protein will go back to the original shape. If another positive charge joins, the protein will move back. Guess what? This is movement. And this movement is what creates life. So the secret of life is very important. A body is made out of protein. Protein molecules wrap themselves up so the charges are balanced. But if an environmental signal comes in and sticks to the protein, it changes the charge. But when it changes the charge, it causes the protein to refold and create a different shape. So life is movement. Movement is due to proteins changing shape. But proteins change shape because of signals. So I have a body. My brain sends signals to the body saying, move arm. And what am I doing? I'm sending signals that cause the proteins to change shape, and you can see my hand moves. My hand changes shape, but my hand's made out of proteins. And so the result is simply this. Proteins move, and when they move, the shape change is used to create work. Remember, movement creates an opportunity to do something. If you can move, you can bring things together, or you can separate things apart. So molecule movement, protein movement, is due to not just the protein, it's due to the signal. Signal plus protein equals movement. And I say, what do you think is the difference between a live person and a dead person? They both have the same shape, but the live person can move. A dead person doesn't move. But so, both of us, the live person and the dead person, are made out of proteins. The difference is the dead person doesn't have signals that go to the proteins, so the proteins never move again. And when the proteins never move, we call that a cadaver. A cadaver is dead. No more movement, no more life. So the simple understanding, the secret is this. The structure of the body is due to proteins. There are 100,000 different proteins. Each protein is different because of the sequence of amino acids that make up the proteins. And as the sequence is different, they fold up differently. So the strings that are proteins have different three-dimensional shapes based on the electrical charges in the environment. When a signal comes in that has an electrical charge, either a chemical, which can have a charge, or an electromagnetic vibration, which can have a charge, either of those things, when binding to the protein, can cause the protein to reassemble into a different final shape. But as it goes from shape A to shape B, there's movement. And that movement can be used to create all of life. To illustrate that, let me give you a model. And it's in the following video. This video is the manufacturing plant for a new car called a Tesla. And what's interesting is there are big red machines that you can see in the assembly plant. Consider them to be proteins. Why? Each red machine can have a very specific movement. And it repeats that movement over and over again, just like a protein, very specific movement. I say, yeah, but what can you do with that? And then I say, if you line up all the proteins, and then you start to engage them. So protein A does one movement, and protein B does another movement, and protein C does another movement. You have an assembly line. So watch this video, and look what's happening. The proteins are moving. The red machines are moving. And as they're moving, their movement is used to create the assembly of the car. A whole bunch of machines are creating a car. Look, there are no people in there. What does it represent? Each protein machine, that's my calling it a protein, it's a red machine, but I'm saying consider it to be a small protein in your body. And I say if you put all the proteins in a sequence and each one does a movement just like in this video, rather than building a car in this video, the proteins in your body are building the cells and building the body's structure. And I say, how do they do that? Just the same as you see in the video. Proteins move, and an assembly line of proteins, their movements collectively do creation. And they can synthesize the body, or they can digest food. They can send muscle contraction or muscle relaxation. They can activate the neurons in the brain. By what? Their movements. So, the simple secret of life is this. The body is primarily made out of cells. But the cells are made out of building blocks called proteins. That's the main building block. And the proteins have a structure, so that's where we get our three-dimensional structure. But the movement, where does that come from? I say, that's when the proteins change shape. And then I say, well, what causes a protein to change shape? And I go, a signal from the environment. What kind of signals? Signal can be either a chemical signal, or a signal can be an energetic vibration, a wave. Either one of those that can cause the protein to change shape. And so when you look at the complex life of a human, you have to recognize there are complex proteins, over 100,000 of them, and a whole bunch of complex signals that can alter the protein and change its shape. And as the protein shapes changes, movement or life comes from that. So the secret of life, proteins plus signal. In our last segment, we introduced the concept that life comes from protein structure and then the influence of signals which cause the protein to change shape and create movement, and the movement of protein does the work that we see as biology. Well, back until 1925, Newtonian physics had us understand that the universe was made out of two components, invisible energy and physical matter. And they said that the two don't interact with each other. So energy and matter don't talk to each other. Well, if a body is made out of matter and there are signals that influence matter, according to Newtonian physics, what can those signals be? And the answer was chemistry. Chemistry were physical signals that affected the physical proteins and caused them to change shape. And in fact, the chemistry was built of what is called atoms. In Greek, the word atom means uncuttable, meaning that an atom was the smallest part of the physical universe. And the significance is there were a whole bunch of different atoms, different little particles. The atoms were like grains of sand, and they have different kinds of grains of sand called the table of elements, all different kinds of elements, all different kinds of metals and things like that, iron, etc., sodium, potassium. These are different elements, but each represented a small little sand grain-like particle, uncuttable. But in 1895, things changed. What happened in 1895, scientists started to find there were things inside that atom that they didn't see before. Things that we now know are electrons and protons and neutrons. And we created a new model of the atom. Now it wasn't just a round particle. Now the atom had a shape like a solar system with electrons moving around, and in the center was the nucleus where protons and neutrons were. So physicists said, yep, atoms are cuttable, and there are smaller particles inside, electrons, protons, and neutrons. But about 1925, they started to find a different story, because they said, okay, an atom is made out of smaller particles, electrons, protons, and neutrons, but what are they made out of? And when they started to look inside the atom, guess what they found? Like in this illustration, what's inside the proton? And the answer is nothing. It's not physical. That the elements, electrons, protons, and neutrons are not made out of physical particles. They're made out of vortices of energies, nano-tornadoes, little force fields, very powerful force fields. I go, why is it relevant? The structure of an atom is made out of energy. I go, what do you mean? I thought it was physical. I say, no, it has the characteristics of being physical, but an atom is not physical at all. It is an energy. And the significance has been very important, because all of a sudden we say, well, if atoms are made out of energy and atoms make up matter, such as the human body, then by definition, the human body is also made out of energy. I go, and what's the character of energy? It's invisible. It's a force field. You can't see it, but it is a force field. I said, well, can we understand what energy looks like a little bit, even though it's not physical and we can't see it? And I go, yes. If you drop a rock into a pond, the rock creates ripples in the water. I say, well, that's the water taking on a shape like ripples. And I go, the shape is caused by the movement of energy. Energy is a force that is shaping the water into ripples. And I say, well, then what is the shape of energy? I say, it's the shape of a ripple. It's a wave, just like this, a wave. I go, oh, so energy has a wave character to it. And I go, yes, it does, but you can't see it. But it has a very powerful force. And then I say, wait, then I am made out of atoms, but atoms are made out of energy. And if they're made out of energy and energy is invisible, how can you see me? And the answer is very simple. The lights are on. You go, what does that mean? I go, when a light is on, light is photons, little light particles coming, and when they hit the surface of our energy, our body, the light is bounced back, and what you see is the light. So underneath the light, there's just energy under here. The light is just reflecting off, and you see the light reflection. You don't see me, you see light bouncing off. Simple point. You can't see me in the dark. I'm invisible energy. So all of a sudden it says, wait a minute. We used to believe that the universe is made out of matter and energy. And now quantum physics in 1925 says, no, that's wrong. Everything is made out of energy. There is no separation of energy and matter as we see it. Matter is just a different form of energy. And energy is connected to everything. So all of a sudden I say, yes, I see me right here. You see me physically right here? That's because where the photons of light are bouncing off and coming into the camera. That's how you can see me, the reflection of light off the surface. But they say, well then, is this the edge of my body? Is this where my body stops right here? I go, no. There's energy that radiates out. there's energy that radiates out from all humans. Sometimes we can use cameras like Kirlian photography and see an aura all around the human body that extends from the surface. It's energy. Yes, we are energy beings. And since energy doesn't have an edge, this is just due to where the light is hitting the energy and bouncing back. A human isn't just local here. A human is an energy broadcast out through the entire field. And I say, why is this so relevant to us right now? And the answer goes back to what was the secret of life? The secret of life is a protein responding to a signal. And I say, yes, in our conventional world, we see proteins as physical particles, and their signals must be physical as well. And that's where the drugs come into the story. Your biology isn't working right? Well, that's probably because the signals aren't coordinating your function. So drugs are signals that we swallow. So drugs, we take them in, are signals that are supposed to control our biology and bring it back to normal. But then I say, wait. In 1925, when physics came in, it said, wait a minute, we're not separated matter and energy. Everything is energy. Everything is interconnected. I say, well, why is that relevant? Because if you stop looking at atoms as particles, you'll see them as waves. Energy is in waves. Energy is invisible. But as you see when you drop a rock in the pond, the energy from the falling rock shapes the water into waves. The water is in waves, but it was the energy that shaped them into waves. You can't see the energy, but you can see the shape of energy because the shape of energy is giving shape to the waves. So energy is a wave-like structure. It's not even physical. So if I say, what does an atom look like? In our conventional story, an atom looks like a little miniature solar system with a nucleus in the center. I say, that's an illusion. That was an idea from Bohr, a physicist, back at the turn of the 1900s. But the simple reality is, as we got into quantum physics, we said, wait a minute. The idea that the atom has physical structure to it, that's not really true. Because as we looked into those physical structures, we found that they were just energy waves. So what does an atom really look like? Well, as I said, first it looks like a little solar system. But when you understand that it's made out of energy, it looks more like ripples in a pond. There's no physical center. There's no nucleus that is physical in the middle of an atom. That's an energy vortex. So I say, well, what do atoms look like? Ripples on a pond. And I said, wow, we used to think that physical things would affect our physical body, but now we find our body is made out of energy. Then I say what? Well, energy interacts with each other. So if I drop two rocks into a pond, the ripples come toward each other. And I say, well, what happens? Do the ripples just bypass each other? And I go, no. The ripples interact with each other. They interfere with each other. So in the following illustration, I show what would happen if I drop two rocks at exactly the same time into the water, and the ripples are both going up, and they're both going down, they're both going up and down, and they come together. What happens? Well, what you see in the middle illustration here is as the ripples come toward each other, in my illustration, I show them overlapping. So one set of waves is over the other set of waves. I say, what's the result where they overlap? And I say, add up the waves. So if one wave is +1 and the other wave is +1, then the composite of that wave is +2. If the valley of the wave is -1 and the valley of the other wave is -1, add them up. The valley is -2. So as you can see in the third version, as the waves come toward each other, guess what they do? In the middle, they add up and they make bigger waves. I say, what are bigger waves? I say, the height of the wave is power. More power, the higher the wave. Simple. Drop a little rock into the pond and you get a little ripple, a little wave. Drop a big rock into the pond and you get a big giant wave. So the amount of energy is directly related to the height of the wave. So as in this illustration, we're showing interference. It's called constructive interference, meaning two energies come together and because they're in harmony, they add up and make a bigger wave. And you say, that sounds like a lot of physics. I say, yes, it is. But guess what? In everyday talk, what happens when two energy waves are in harmony and they come together and they make greater wave? We call that good vibes. A vibration, good vibration, meaning the vibration energy, when two waves in harmony come together, create more energy. And that means, look, each atom is an energy. A human body is a collection of energy. If I connect with another human and we both have the same type of energy, guess what happens when we come together? Together, our energies combine and create what is called constructive interference, or good vibes, or more power. And that's why when you seek things in your world, you look for things that give you more power. And what does that mean? Whatever that thing is, it has energy that is in harmony with you. And energy is life. The more energy you have, the more life. So what do you think we do? Animals, people, look for energy in their world that gives them more energy. Good vibes. Because when we're finding good vibes, we're enhancing our life. Why? Our energy is greater, and energy is life. Greater energy, greater life. Now, I want to show you something a little different. It almost looks the same, and that is this. Remember, if I drop two rocks into the pond, the ripples start coming toward each other. I say that's when they interfere. Now, the first time I showed you, the two rocks were dropped at exactly the same time, exactly the same size rocks. They hit the water at the same time, and the two waves are coming together, both going up, both going down, both going up. That's in harmony, and the result is constructive interference. But in this chart, I want to show you something different. I'm going to drop one rock before I drop the other rock. So they're not in harmony anymore. Why? Because this wave is going up and this wave is going down. When this one's going down, this one's going up. And in other words, they're not in phase. They're not in harmony. I said, well, what happens when two waves that are not in harmony come together? And I say, well, in the diagram in the middle here, I will show you the fact is, yes, the same as before. The two waves come together, I overlap them, and I say add up the values of the waves. One wave is +1, the other one is -1. I say add them together, 0. The other wave is -1 and +1. Add them together, 0. I say, oh, well, look what happens when two out-of-phase waves come together. You can see them coming together out of phase. And then I say, what happens when they come together? And the answer is they cancel each other out. The relevance is very important. Two waves in harmony add up power, called good vibes. But two waves that are not in harmony come together and cancel the power, and that's called destructive interference, and it's also known as bad vibes. And you say, so what are vibes versus bad vibes? And I say, they're how you experience the world, the signals of energy that come to us. I say, why is it relevant? Energy is life. So therefore, as you go through life, you seek things that give you good vibes, things that are in harmony with you, people that are in harmony with you, food that is in harmony with you, pictures on the wall that are in harmony with you. In other words, how you decorate your house, you put things in your house that give you extra energy. So when you sit in your house, you feel more energy. But if you go into a neighbor's house and they have different kinds of energy, guess what? The house could make you feel very uncomfortable. The pictures are, the colors on the wall. And I go, oh, this is bad vibes. And I say, what's the relevance of good vibes and bad vibes? And the answer is simple. Vibes equal life. And I say, well, relevance. I say, let's go look at a snail. I say, is there a school that snails go to know what to eat and where to go and how to live their life? Nope. There's no snail school. So I say, how does a snail know how to save its life? And the answer is simple. It reads energy. The snail will move toward where the energy is better because that's where growth comes from, where life comes from. But if the snail is moving and the energy gets to be bad vibes, that means taking away life. Guess what the snail will do? Will move away. So like snails, people do the same thing. We move toward things that give us extra energy, good vibes, and we move away from anything that gives us bad vibes because bad vibes takes the energy out of the body. Energy out of the body means loss of life. So here's a simple point. Unaware, your brain is unaware what you're doing, but what are you doing in your life? You're seeking things that give you energy in the form of constructive interference, energy that enhances your vitality. The higher your vibration, the more life you have. And you will avoid anything that takes away your vibration, bad vibes, because if you're losing your vibrations, you're losing life. So what's the relevance of the new physics, quantum physics versus Newtonian physics? In Newtonian physics, matter was separate from energy, and matter could only be affected by other matter. If you want to change your body, you had to use chemicals, drugs to change your body. But guess what? Now we find that the body and the drugs aren't physical at all. They're just energies. I say, but what do? We seek energies that give us more life, and we avoid energies, bad vibes, that take away our life. And the relevance about this is a body can respond to energies that look like chemicals. Remember, a chemical looks like matter. Here's a physical pill. And I go, that's an illusion, because whatever is physical is actually made out of energy. And I say, well, here's a physical pill, and here's an electromagnetic vibration. I say, both of them could heal you, because they're both energy. And you know what's interesting? Invisible energy, electromagnetic waves, are more powerful than conventional chemical-like drugs. The invisible energies, the waves, are much more efficient as signals than are energies that look like chemicals. They're not as efficient. So the whole idea is this. Life comes from proteins responding to environmental signals. And there are two types of signals. Signals that look like chemicals and physical signals, or signals that are energies, thought, electromagnetic fields. And I guess what? Between the two, the most effective signal is not the signal that looks like the chemical. The most effective signal altering your life are the invisible signals, the energy signals. Thought, in fact, is one of the most important signals that control your biology. A thought is a vibration. It is an energy. You can put wires on a person's head called the electroencephalograph. And what are you reading? Brain vibrations. Brain takes thoughts and creates vibration. Thoughts create energy vibrations that affect our body. And so I can say, yes, I can affect my body with what looks like a chemical drug, or more effectively, I can affect my body through my thought and my consciousness, which is a better form of communication than is the energy that looks like a chemical. So, life is due to signals plus protein. The signals that are most effective in controlling life are not the signals that look like chemicals. It's the invisible signals, the ones that are the electric energy in our field, all around us. And once we understand that, then we will get off the drugs and start healing with energy signals. That is the future of health.